To the series of video lessons on diodes, semiconductor diodes. So far, we've talked about, just to summarize, diodes, their structure, what they do. We also talked about the models, the three different models we use to study diodes. And then after that, we also talked about how we use diodes to convert AC to DC, half wave and full wave models. Okay, so now the next thing that we are going to use, the talk about is another use of diodes is we can actually make diodes into light emitting diodes. Pretty cool. Okay, so in this chapter, in this part of the chapter, we are going to describe why we use LEDs compared to incandescent bulbs, and why we must put a resistor in series with a LED. Okay. So LEDs are special types of diodes that give off light. You have seen these before. We've used them in our ALP classes. So why do we use LEDs? Now, in many of our homes, there are still fluorescent bulbs. There's still incandescent bulbs. In fact, incandescent bulbs are coming back in popularity now because it looks pretty cool, especially in those hipster cafes. Yeah. Uh, but LEDs are used because they have a longer lifespan and they are more energy efficient. Okay, they consume a lot less energy. However, LEDs usually cost more. Okay, so what is the symbol for LEDs? It's the same thing. First, you draw a diode, but the only difference is that you add in two arrows here to indicate that they are light emitting. And how do we identify which is the anode and the cathode of a LED? Remember, the D here stands for diode. And if you have a diode, means you have a anode and a cathode. That means you need to forward bias this diode in order for it to work. So a couple of things. These are the three methods. Let's use this diagram here. First way is, of course, the long leg is the positive, the anode. The short leg is the cathode. And if you can see through the plastic covering itself, the bigger plate is the cathode and the thinner, smaller plate is the anode. Okay, so these are some features that help you identify the anode and the cathode. So please remember this. The anode is the smaller plate and the larger plate is the cathode. Okay, the longer leg is the anode, the shorter leg is the cathode. All right, so remember this. Okay, so this is a circuit for a lighting up an LED, and you notice that we don't, in fact, it's quite a bad habit to straight up hook up a LED like so, because you run the danger of blowing up the LED. So this is a big no, no, okay? CJ, no, no. Okay, so same thing, we have to forward bias the LED for it to work. Okay, this source, because remember it being still a diode, it still also has a forward voltage. It has a knee voltage, a minimum voltage for this fella to light up. And therefore, the DC source must be higher than the forward voltage of the diode. Okay, so typically the VF for diodes are between 1.7 to 4 volts. You got to check the specs of the diodes you buy. So whenever you use a diode, just remember this will have the forward voltage drop of VF. And we always use a current limiting resistor in series with this to protect your LED. Remember, if I have too high a current running through it, it is going to damage your LED. Okay. So what value of R should I use? Now, typically in our coursework and whatnot, all you need to do is, I always say, you know what, just use a 1K resistor and be done with it. But if you really want to calculate it accurately, you can. So to calculate the value of R, I take the EMF minus the forward voltage and what is the max current that it can take. If the max current is 20 milliamps, okay, the current rating is 20 milliamps. For it to work perfectly, nicely, 20 milliamps, I take this value, put it in here, and I find that I would go to the cupboard and look for a 350 ohms resistor. Okay, so let's take a look at this worked example. They want me to calculate what is the current running through here. The forward voltage, VF, over here is 2 volts. So I got to take into consideration this 2 volts. Okay, so I've got 5 volts here, but I remember that I have to take away 2 volts. So therefore, the voltage across the resistor here is 3 volts. And using Ohm's law, V equals to IR, I work out that I should have 14 milliamps flowing into the resistor and the diode. Okay? So example 7.5, pause the video here. Try it yourself now. Okay, so hopefully you did try it. So explain the need to connect a resistor. Now this resistor is a current limiting resistor, so it limits the current. And why do we need to limit the current? To protect the LED. Okay, so let's look at part B. What is the current flowing through here? Assume both LEDs are identical, VF 2 volts. Okay, so I have a voltage drop of 2 volts here. I've got a voltage drop of 2 volts here. Okay, so I want to find out what is the current here. Because remember, the current will be the same as this. Okay, so first of all, I got to find out what's the voltage drop here. 10, I start off with 10. I drop by 2, I drop by 2, and therefore I'm left with 6 volts here. So applying Ohm's law, I equals to V over R. V is 6 volts. R is 330. Let me pause. Okay, so after I press my calculator, I find that this gives me 18 milliamps. Okay, so this is how LEDs work. So why they give off light when you apply a certain voltage across it, that's not in your syllabus. If you do want to find out, there are quite a number of YouTube videos about it. It really depends on the material that the LED is made of, okay? And the doping process. All right, so that's it for LEDs. In the next part, we are going to see what happens when we put a bunch of LEDs together to make a 7-segment display. See you in a bit.